So there was a good suggestion asking if I could kind of replace what we used to do in lecture, where I'd go over sample problems or go over some of the sapling problems, if I could replace that with doing videos on that, which I thought was a great idea. So I'm going to do that for the last two homework assignments. So this is for homework 9, the one with the circuits and the Kirchhoff's laws and stuff like that. So I just picked out, there's only 5 problems, but the 2 that I think you're most likely to struggle with, I picked out those to kind of explain the setup for. And then of course you can ask if you want tutorials on some of the other ones. I can do that too, okay? Just let me know. Okay, so the idea of this one is just, so I drew the circuit here so that you could see it. And the idea is that you're trying to find the equivalent resistance of all of this mess. And the idea of the equivalent resistance is simply that it's, what's one resistor, right? So from the point of view of there's current coming through here, let's say, could be the other direction, but it doesn't really matter for this. The current's coming through and it's going to encounter, so there's like a battery somewhere in the circuit over here, maybe. And you're trying to figure out what resistance the current coming through the battery is going to encounter. And the notion of equivalent resistance is just replacing everything that's happening here with one single resistor that would have the same resistance from the point of view of the battery, right? So that's the idea behind it. And the rules for it are that if you have 2 resistors, remember, and this is the opposite, hopefully you saw this in the lecture notes, this is the opposite of the way it is for capacitors, right? So capacitors in parallel, you add the capacitance, whereas for resistors, it's in series that you add them, and in parallel, you have to do 1 over the, add the inverses. And hopefully, let's see, last week's lab gave you a lot of practice with that, where you really got to see kind of where those rules came from, right? You saw the parallel circuits and how that lowered the resistance and stuff like that. So this problem is just applying that to solve a more complicated problem. Okay, so what I'm going to do then is I'm going to go through just step by step, and I'm going to replace. So I'm going to do this one first. So for now, I'm just going to write this, right? I mean, that's what I'm after, is to find the overall R equivalent. But I'm going to do it in steps. So first, I'm going to focus on 1 and 2 in parallel. So R1, sorry, I better put this further away, otherwise it's going to be confusing there. So let's just scroll down here. So I'm going to have R1 and R2 in parallel. Maybe I'll just write it like this. So I'll say 1 over R1, 2 equivalent, right? That's the equivalent of this parallel segment. That's equal to 1 over R1 plus 1 over R2, right? Okay, and then notice you have to be a little careful here. So once you find a number for this, right, you'll substitute in your values and find a number, substitute in your values for R1 and R2. You'll find a number for this, and you have to be careful to remember that that's 1 over R1, 2 equivalent. And so then you have to take the inverse of it to solve for R1, 2 equivalent, right? Okay, and then now I'm going to go ahead and I'm going to be more methodical about this than probably would have to be, but just to make sure you kind of see how the process goes. So now I'm going to rewrite the circuit again, but now I can replace it with whatever number I get for this R1, 2 equivalent will go in there, and then this one's R3, and then this one's R4, and then there's R6, and then I've got R5 here. Okay? So now this part is fairly simple. I just add those 3. Okay? And so then and I can, in fact, I'm not even going to redraw this one. I think I can just say that this top part, let me just do this. This top part is just the sum of all those, right? I can just treat that immediately like it's one resistor. And so then now I'm going to do the same process of, I can find, I think I've probably given you enough that I don't have to do all the details here for you. I can do another parallel formula, right? So the equivalent parallel resistance of this combined with this will be 1 over this one plus 1 over all of this will be 1 over the equivalent of this part. And then once I've found that, then all I have to do is add that directly to this one, because then that equivalent is in series with R6. And then that'll give me at the end the net result of the final R equivalent that I'm looking for. Okay, so hopefully that gives you enough for the structure so that you can kind of see how to do that problem.